Up until now, we've been getting a good idea on how hardhat works, and that's great, but we now need to dive into working with Solidity and actually building our smart contract. Before we start writing the code, let's take the time to actually understand what it is we're doing right from the ground up. So if we go back to our project plan over here, we have our smart contract section, our testing section, and our deployment part of this project. Right now, I want to hone in on and focus on the smart contract section. Note I made a little correction to this last block here since I think 2 videos ago. So the first step here is we want to be able to request a flash loan. But where are we actually going to get that flash loan from? And what even is a flash loan? Now remember, a flash loan is where you are able to borrow money, so you can borrow liquidity without any collateral, without having to give your name, your address, any timeline, and you can borrow, millions of dollars if you want to, or $10. The catch is that you have to pay that flash loan back within a single transaction. So at the start of a transaction, we can borrow money. Then we do work with that money, i.e. we do an arbitrage or a liquidation or whatever it is you want to use that for on the blockchain. And provided that you've paid that money back, which is the last step here, you pay that flash loan back, then that whole transaction is successful. So if you paid the flash loan back, the transaction is good. And if you pay it back with the fee that you're due to pay it, plus you have excess, that excess is for you to keep. So you can use other people's money, i.e. the liquidity from a decentralized exchange, in this case, PancakeSwap V3. We can borrow that money as long as we pay it back, and we can keep any excess we make. Hence, flash loan arbitrage. Now, where can we get that money from specifically? Well, PancakeSwap V3 actually has a flash swap function where we can get a flash loan as part of a liquidity pool. So if you look at this diagram, for example, Uniswap V3 or PancakeSwap V3, same thing, is a smart contract of smart contracts. It's not just one contract. And so this is a very simplified version of what we'll be working with, but I'm actually going to show you the smart contracts and walk through them in a minute. But just for now, we have a factory. A factory is a smart contract that essentially creates other smart contracts. It deploys other smart contracts autonomously. And so we have a factory contract, and then we also have a pool within that factory, and we have lots of pools. So Uniswap V3 or PancakeSwap V3 have loads of liquidity pools, and that could be a pool of, I don't know, it could be WBNB and Cake, or BUSD and WBNB, or whatever mixture of tokens you like. There are different pools, and the amount of liquidity of each token in that pool determines the price. And so this is an automated market maker model, and this is how PancakeSwap V3 or Uniswap V3 works. In terms of where the flash loan comes from, it actually comes from the pool address. Here, if we're going to be using PancakeSwap V3 to provide us with the flash loan, which is what we're doing in this series, we actually get it from the pool. Now, PancakeSwap V2 has a slightly different model, and it works differently. If you're interested in how to borrow money from PancakeSwap V2, check out the training courses at coderaiders.com. There's one there. It's a bit dated, but here we're going to be using PancakeSwap V3. Once we've got that money, we can then perform the swaps on whatever exchange we want. And it doesn't have to be a PancakeSwap. It can be any exchange you want, provided you know how to do a swap using that exchange. And in this series, we're actually going to use PancakeSwap V3 and PancakeSwap V2 to perform swaps. Once you have that swap done, that's when you would go back and repay this flash loan. So let's go and take a look actually at the smart contract so we can understand all of this a bit better. And we'll start here with the factory. So I'm going to open up a browser tab here, and I'm just going to open up BSC scan. And the next thing I'm also going to do is just Google PancakeSwap V3 factory contract address. And you'll see I get this link over here. So for the docs, Pancake V3 factory and V3 contracts. Now it's this V3 contracts that I'm actually interested in for helping in this video. And I will provide a link to this in the description of this video too. So the first thing to take note of here is we have a whole bunch of contract addresses. We've got our Pancake V3 factory. We have something called a pool deployer. So this is a hint as to what that might do. It might actually be the thing that deploys the smart contract. And this actually gets called from within this V3 factory. Just take my word for it for now. And then we have a whole bunch of other contract addresses. We have a router, and we're working with the Binance Smart Chain. So we're going to be on this column here. So we have a ISwapRouter. This is what will allow us to perform a swap. And there's other contract addresses too, of which we don't need to know about them for this series that we're going through. So if we go up here to our Pancake V3 factory, and I just copy this address, go over here to BNB scan and paste it in, let's actually take a look at this. So here, let's go to contract and read contract. And you can see here, it has a bunch of functions I can call here. One of them is get pool. Another one is pool deployer. If I click on pool deployer, you can see here it ends in 1C9. And if I look here, you can see this contract address ends in 1C9, meaning this deployer contract is part of this factory contract. Let's take a look at this function here, get pool. And get pool is asking for 2 addresses and an integer. Now, what might those actually relate to? So if you're not sure how to investigate smart contracts, this is how to do it. You can click here on code and then just type in up here the name of the function you want to call. So get pool, and I'm going to just keep hitting enter until I actually see it here as a function. And there we go. Here I have the interface for that function, and it's saying here get pool. The first item relates to a token A, the second one relates to a token B, and the third one relates to a fee. Now, the interesting thing about Uniswap V3 and PancakeSwap V3 is there's not just one pool. There's different pools with different fees, and the fees relate to the rewards that are distributed to liquidity providers in those pools. And there's different levels of fees. I think the levels are 100, 500, 3,000, 10,000. Could be wrong on that, but I think those are the different fee breaks for different pools. And so there's not just one pool for example, WBNB and BUSD. There's multiple. And this is where there's a lot more, let's call it depth with Uniswap V3 and PancakeSwap V3, because we have these different fee structures. Anyway, regardless, if you have 3 pieces of information, it will actually return the address of a pool. Well, let's actually go and test this out. If I go back to read contract and back over here to our get pool function, and then I'm going to open up another window here of BSC scan, and I'm going to get the address for WBNB, and there it is, wrap BNB. So we'll use this here as a pool, and I'm just going to put that as the first address. It doesn't have to be the first address. And then I'm going to get another one, which will be BUSD, which is essentially US dollars, but it's the Binance US dollars peg. And let's grab that. So there's another one. I could pick, cake or whatever token you want from the Binance Smart Chain. And then in terms of the fee, I'm just going to use the break 500 here. Now, how do I know about 500 or 3,000, 10,000? I've read the Uniswap V3 documentation, and PancakeSwap V3 is just a fork of Uniswap V3. So when it comes to interacting with the blockchain, understanding and reading through the documentation is sometimes a prerequisite if you really want to understand what's going on. So here, if I just go and hit query, you can see it gives me this pool address here, ending in 6687. So this is telling me what the address would be for this liquidity pool, this mixture of these 2 tokens. If I now click on that, there is indeed a smart contract. So you can see here, I'm now in 6687. And if I go and look here at the contract and read contract, there's a whole bunch of things here that I could call, including a token 0 and a token 1. Now, notice here that the token 0 ends in 95C. And if I look here, the BUSD ended in D56. So if I go back here, D56 is actually token 1. So that means WBNB was token 0 and BUSD is token 1. And the way it knows how to order those tokens is actually based on which one is greater than the other. So I could say, if token A is greater than token B, put token A as token 0, for example. So if I'm just going to cut that out here, I'm going to swap these two tokens around so that I can show you what I mean. If I actually swap these the other way around and hit query, you'll see I get the same address. It's still 6687. So there's actually a swap that happens to order which one goes in what order. And when it does that, token 0 actually ends up being the WBNB, and then the BUSD is token 1. And so we have a liquidity pool here of these two tokens, and it could be any tokens. These are the two tokens we'll continue to work with. So when we build our smart contract, we'll make it so that you can borrow either WBNB or you can borrow BUSD, but you can also borrow other tokens from other liquidity pools. I'll leave that to your imagination for whatever you want to use this for in the future. That's reading the contract. What if I go to write contract? What are some of the writes I can do to the blockchain? Well, here is one called Flash. Now, if I open this up, I can put in a recipient for the Flash loan, the amount of token 0 I want to borrow, and the amount of token 1 I want to borrow, meaning I can borrow a mixture of money. We're going to keep it simple. We're just going to borrow either WBNB or BUSD. Remember, token 0, token 1. And then the data, this data can be any information that I want. It can be anything, but it has to be condensed into a set of bytes. So it can't be human readable code. It needs to be byte code. And I'm going to show you how to do that. But we're going to take human readable stuff that you and I can understand, and we're going to put that into byte code that can be passed into this request for a Flash loan. And so when we pass that in, that data will be passed over to our execution layer when it comes to doing swaps. And the reason for that, let's go back here. The reason why I'm going to put swap information there is I needed to know what tokens and what exchanges do I want it to swap on. It could be any information that I need for the purpose of that Flash loan. And so what we're going to use it for is arbitrage. So I'm going to say, okay, try to arbitrage, these tokens on this mixture of PancakeSwap V3 and PancakeSwap V2 exchanges. But it could be any exchanges you want, provided you've got the code for those exchanges. You'll learn how to do all of that here in the series. But this is where the meat of the information is. So great. We now know we have a factory contract, and we have a pool contract, and we have actually many pool contracts that get created from that factory contract. And I should even say from the deployer contract of that family contract or factory contract to be specific. But nonetheless, we have many of these. We're going to work with just one of them, which will be, the BUSD and WBNB pool with a fee of 500. And then we need our code later on, which will enable us to do the execution, i.e. go and swap the tokens and then eventually pay back the Flash loan. Remember, if we don't pay back the Flash loan, then no money, no honey. Nothing ever happened. So that is what we need to go and now build. So let's go over here to our Visual Studio Code, and under contracts, I'm just going to create a new file, and I'm going to call that Flash loan with a capital F and a capital L.sol. And it doesn't have to have capitals like that, but that's how I'm going to do it. Now, in the description of this video are the imports. I don't want to spend time typing out the imports with you here because that's not a good use of our time. So just go to the description of this particular video and paste in the imports data that I've put there, and you will have something that looks like this. Here we have our solidity, pragma version. We're also importing in hardhat console, and this is to enable us to do console.log using hardhat. So hardhat enables us to console log the outputs and various things we want to print out to the terminal, because Solidity actually doesn't have that. This is a hardhat thing, and hardhat treats that in a certain way. So we're going to take that functionality here, and then we need to import a bunch of interfaces. And these interfaces, other than this TransferHelper, I'll bring this down here, these interfaces allow us to call the various functions of these different contracts, these different functions within these contracts. And so we already have these because we had them in our package.json. It's all here within our node modules already. So we've already gone and installed all of those. So these are readily available for us to use. So for example, if I just look at the ERC20 and the I stands for interface for ERC20, you can see here it's got a whole bunch of things that allows us to call now. We can call balance of, we can call transfer, we can call allowance, and approve transfer from. These are all standard ERC20 functions. And so having these functions means this is essentially an ERC20 smart contract. So now that we have that, we can define that as the interface for a given address. And that way we can call those functions from our Solidity smart contract. So that's what all of that does. The transfer helper is going to help us actually make transfers. The safe ERC20 is an extension of the ERC20. We will attach it to this type. The safe ERC20 essentially allows transfers to check whether or not a transfer was successful or not, because the standard ERC20 doesn't do that. And we need to be able to do that if we're dealing with swaps on PancakeSwap V3 and PancakeSwap V2, because different ERC20 tokens will have, different levels of detail when it confirms transfers, etc. And so we need to make sure that we have transfers confirmed as either successful or a failure in order for everything to function properly. And so that's what this extension does, and we'll attach that to this. And safe math, we may not use this, but sometimes you can have overflow or underflow when it comes to working with a uint, so an unsigned integer of 256 bits, for example. And therefore we need to be able to add or subtract U256 amounts safely. And that's what this would enable us to do. We may or may not use it. I'll actually be showing you the functions from a BSC scan point of view so you can see them. But if I hit Command and click on this, I can go into these imports and I can go right into the depths here. So for example, here you can see the function for swap exact tokens for tokens. We would pass in an amount in, an amount out minimum that we would expect. We can just set that to 0. And it will go and perform that actual swap for us. And so this is the interface. It tells us what are the types that we need to pass in and the variables we need to pass in for this to work. So I can close those now. We'll look at that in more detail later. But that is how to go and interrogate what these do. So this one's for PancakeSwap V2. These two here are for PancakeSwap V3. One is for interacting with the pool, and the other one is for actually performing swaps. So that's what the imports are doing. Let's actually go and create our contract. So here I'm going to say contract, and we'll call this flash loan with capital F and capital L, open and close curly braces. And so this will be where we have our smart contract for our actual flash loan. When the flash loan smart contract is actually deployed, so when we actually launch this onto the mainnet, for example, or even our own local blockchain here, our forked mainnet, we need to specify, what is the pool going to be that we want to work with? And you don't have to do it this way. It's just the way I'm choosing to do it. And we'll do that with the constructor. The constructor is something that initializes this smart contract. So when we go and deploy it, we can pass variables that we want to store for it for life. And here I'm going to pass in here an address, and we'll call that token 0. And the other one we'll pass in will be an address, and that there will be token 1. So I'm going to put the underscore token 1 like that. And then here I'm going to put uint24. And you don't have to use the underscores. This is just how I like to do it. And let's put in underscore fee like that. So this way I know that these are the variables being passed into the function because I have these underscores here. And so what will token 0 be? Well, here we can declare up here what token 0 will be. It will be IERC20, so the interface ERC20, and this will be private and immutable. And we'll call that token 0. And the same thing here for token 1. So now we know what types those are going to be. And I can say token 0 is going to be equal to IERC20. And that there we're going to pass in token 0 like that. And the next one will be token 1 like such. Now we also want to have our pool defined, which is the whole point of passing in this token 0 and this token 1. So we are going to need to know what will the pool address be for these. Now I could just fix it here, but I want to show you how it's actually calculated, because by showing you this the long way, it's going to give you such a deep understanding of how to interrogate these smart contracts to figure stuff out yourself, because no doubt you want to be able to do more than what I'm just going to show you in this series. You might want to use this for other things in the future. So let's really go to town with this. The next thing is going to be our pool. So let's define what type that's going to be. That's going to be ISwap V3 pool. Remember, PancakeSwap V3 is just a fork of Uniswap V3, and that will be immutable pool. So we just call that pool. And so what is pool going to be equal to? So pool will be equal to this Uniswap V3 pool. But now what I want to do is actually go and calculate what that pool address is going to be. And the reason I want to write it in a function that will allow us to do that, or something that can be called to do that, is so that when you use this in the future, you can just put in any tokens you want and not have to find the pool address. It will just work it all out for you. So that's what we're going to write here. We're going to need a function here, which we'll call getPool, and we will pass into that token 0 and token 1 and the fee. And those are the 3 bits of information we'll need in order to get the pool. If we were to go and run this now, it would fail because there is no function for getPool. We will write this down here somewhere. But before we can go and do that, we need to understand, how do you actually compute this pool address just by passing these 3 things in? So I'll tell you what, let's go and comment this out for now so that we know our code is nice and clean and that technically it would run. So let's go and comment this out, and let's go and do some investigation as to how this actually works by looking at some contracts. So if I go over here, for example, to our list of addresses, so here it is over here, and let's think about this logically. The one time that you would need some code to know what pool you're using is if you're performing a swap. So let's investigate this swap contract a bit, the one that ends in B14. So I'm going to copy this here, and I'm just going to go to BSC scan, and I'm going to paste in that address, and I'm going to look here at contract. Then let's go over to write contract, and here's where you actually perform swaps. So for example, here I've got exact input single. Great. This is where I would put a token in, what token out I want, what fee break I'm using, who the recipient is, the deadline, and the amount in, the minimum I expect out. And this here you can just ignore. We'll just set this to 0. So this is the information I pass in. But how does this swap contract know what pool it's doing that swap in? Because it must be using a liquidity pool. But I'm not giving it a liquidity pool address. I'm giving it the token in, the token out, and the fee. That could be very similar to how we think about token 0, token 1, and fee. Or token 0, token 1, and fee over here. You can see we're using the same information. So it must know how to compute and calculate that address. Now, if I go and look at the actual code here, I could type in compute address. And so here we can see it's calling this compute address. But look, it's the getPool function that is being called here. And so this is very interesting. If we have this function that is essentially then returning a computed address, we now need to know what that computed address function is. And so if I go and hit enter again up here and hit enter again, there we go. There is the function for computing the address. And so there's a very specific way you can do this with Solidity. And if you have never heard of create2, I definitely recommend you just research a bit of create2 if you want to understand how these factories actually work. How can you know an address before you even deploy it? This was an upgrade that happened in Solidity some time back. So having an understanding of that will help give you an understanding of this. But nonetheless, here is the code to compute the address. So we now know how to go and get that, and we're stealing it from a logical place because we know the swaps don't have it, so they have to calculate it. So we're just going to steal what the swaps are already doing. So let's go over here to our Visual Studio Code, and I'm actually just going to create a library down here to interface with, and that will just steal that code. So here I'm going to say library, and I'm going to call this pool address. And within that, we're going to need our function compute address. So if I copy this code here, I'm literally just going to steal that, paste it in over here. So there we go. I've now got my function for compute address. And here you can see when we go and compute the address, we're passing in the deployer. So this will be the deployer address. So we'll need to know what that is and set that up. And we're passing in something called a key. And this is of type pool key. And this will return the address for pool. And that address is calculated like follows. It says here key.token0 is less than key.token1. So this needs to make sure that the ordering of the tokens is correct. And provided it is, it will actually go and calculate and compute the correct address by encoding the data we're going to pass in. And that data is going to be the token 0, the token 1, and the fee. And notice here, we also have this pool init code hash. Now, I don't know what this is. So we don't have this and we don't have our deployer. So let's actually go and get those set up. The first one that I'm going to set up is going to be this pool init code hash because we need that. And I'm going to go and steal it from here. So now if I go pool init code hash and I scroll up and I copy this here and I hit enter a few times, it should bring it up. There it is there. And here it is. Here it is defined. So let's just copy this and paste that here into our pool address. Now remember, if you just want to know you've got exactly the same code as me, you can just go and download this from Code Raiders. For those of you who are members, remember it's completely free. All this code is already there, ready for you to go and use with a walkthrough video of how to install and run it. So here we have our pool init code hash all defined here, but it doesn't know who this deployer is. We've not defined that anywhere. So where are we actually going to go and define this deployer? Well, I'm actually going to define it in our Flash Loan smart contract up here. And I'm going to say that our address, private, and this will be a constant. This will be called deployer. So the deployer, I can just simply go here to the contract and here it is. It is 1C9. We know what deployer is being used. We could also see that in the smart contract itself. But let's just go and copy it from here. So I'm going to copy that and I'm going to paste that in over there. And there is our deployer address. So let's go and take a look down here at what else we might be missing. Yes, we have got our pool init code hash. We've got our deployer, but we haven't got our key defined. So what I'm going to do is just go and structure this here. And let's create a struct called pool key. And pool key is going to have an address, and that's going to be here token 0. And it's also going to have token 1. And it's also going to have a uint 24, and that's going to be fee. And so that is the struct for our pool key. But we also now need the function for get pool key. And so that function, if I stole it from, or if I steal it from the smart contract we saw earlier, I'm just going to type it out here though. That get pool key looks something like this. We had an address here, which would pass in, say, token A, and we had an address token B, and we had a uint 24 here, which will be our fee. And there we go. So we'll pass those three things in. And once we have those, that there is internal pure, and it will returns the pool key. So this is exactly how it was set up in the smart contract before. And the logic here is if token A is greater than token B, then token 0 needs to be token B. So whichever token is less than the other has to be token 0, because here I could pass in any tokens to get a pool key, right? Any tokens. So I need to make sure the ordering is correct. So here I could say something like if token A is greater than token B, and therefore token A and token B, so I'm going to reorder these, token A and token B is going to be equal to reversing it. Token B, comma, token A. So this is just a shorthand way of doing exactly that. And then here we need to return the pool key, open and close parentheses, and in there we're going to pass in our struct, which will be token 0, and that's going to be token A. So token A is now definitely going to be token 0 because we've made sure the ordering is correct for that. And token 1 is going to be token B. And here the fee is going to be the fee. And there we go. Let's just add our semicolon on the end here. And remember to add the semicolons everywhere. So this is something that can definitely trip you up. Just make sure you've got all of those added. So now if we go back up to the top here, remember we need to call a function called getPool. So let's now write that function out that will go and utilize everything it needs to actually calculate that pool address. And so here we can write out function, and that's going to be getPool, and open and close parentheses. And there we're going to pass in the address here, which will just be token 0, and the address, and sorry, I'm using some Rust syntax here. I shouldn't be doing that. Address token 1, like that. And then uint 24, which will be our fee. So we're going to pass that in there, and that's going to be public pure returns, and that's going to return an address. And how's it going to do that? Well, the first thing we're going to do is create our pool key, which is going to be PoolAddress, which is our library here that we're now calling, and that is going to be .pool key. And that pool key there needs to be assigned as memory pool key. Now without the square brackets, so pool key, and that's going to be equal to PoolAddress dot get pool key. And you guessed it, we need to pass in token 0. We need to pass in token 1. And we need to pass in our fee. And here again, I'm just using the underscores when I'm dealing with the variables from the actual parameters of a function. So if you're wondering why I'm using these underscores here, that is why I'm doing it. And in fact, here, I need to pass in an underscore just to be consistent there too. So there we are, there's our fee. And let's close that there with a semicolon. And then let's here return our pool address dot compute address, because remember we've stolen this down here. And we can now pass in our deployer, because remember it expects to get deployer down here. And we defined our deployer up here within our flash loan contract, which is where we're defining the function for getPool. And then here the pool key. And so let's talk through what's going on here. When we deploy this flash loan smart contract, which right now isn't taking on any flash loan, we are going to define a token 0 and a token 1. I'm going to choose those to be WBNB and BUSD, but you could select whatever you wanted. But to follow along, I suggest you select the same. And also a fee. The fee I'm going to be using is the fee break of 500. So when I pass those in, that will assign token 0 and token 1 forever to this contract. And the pool that I'm going to be using, the pool address, instead of just hard coding that in here, or just simply providing that pool address, I'm actually going to calculate it using what we've defined over here as getPool. And so when we pass in this token 0 and token 1 to getPool, the first thing it's going to do is get the pool key, which it's calling from this library we created here. And that is taking whatever we pass in and just reordering it so that it's token 0 and token 1 is actually the right way around. And it's passing that in here with the fee. And so the key is basically just an object. It's just this struct over here. And so once we've got that pool key, we also need the deployer as well. And so the deployer we're just hard coding in because it's never going to change. It's always going to be the same. And we pass those into another function, which is computaddress. And so here is this PoolAddress.computaddress, and we're passing in that deployer and that key as mentioned. That is then making sure that the token 0 is less than token 1. So this just is a guard. It makes sure that's correct. And it will use this code that we're stealing here from the swap contract to make sure, and here I'm just indenting these back one because of my VS Code, but to make sure that this address is correct. And so we should now get the same address as we saw on BSC scan if we go and run this. But how do we go and run it? How do I actually go and deploy this and test it's working? Well, that's what we're going to do here in our flash test script over here. So the first thing I'm going to do is just open up a terminal here because I'd closed that before. And I'm going to go npx hardhat compile. And that's going to compile my smart contract. So it says here Solidity version 0.8.13 is invalid or hasn't been released yet. Run npx hardhat clean global and try again if you're sure it has. So let me try that again. And run hardhat compile, and I still get the error. So let me go over here to hardhat.config.typescript. And indeed, look here, I've got a space after these numbers here. So that's what's causing the issue. Let me remove those and run this again. And there we go. It's downloading the Solidity compiler that it's supposed to. And let's see how it does. And it's picked up another error here. It says explicit type conversion not allowed UN256 to address. And let me go here to my flash loan sol. And indeed here I'm passing in token 1 without an underscore. So let's go and correct that very quickly. And let's see here what else we've got. So that's corrected, sorry, this error over here. But the other error was down here on row 57. So here where I look at the address. And so it has an issue here with the uint256 that I'm using here and converting that to address. Now, just take it from me. I've seen this issue before. And the way to actually resolve this is instead of using uint256 here, I'm going to use uint160. And that there is actually then going to take in another uint. And I'm going to open and close parentheses there and move this kekak256 here within that. And so now I've got an address, which is actually computing here a uint160 from a uint, which it's getting here from this same calculation that we stole from before, from the swap contract. Now, the exact reasons for that is because of type conversions here. And obviously the smart contract that we've taken this from is working probably with different types. And so this is just some code I used before to get around that problem. Let me neaten this up by putting that down a line. That just helps with the readability. And there we go. That looks a bit better to me. And also let's just make sure the spacing of all of this looks correct. All right, great. Let's try and compile this again. npx hardhat compile. And there we go. It has successfully compiled our smart contract. The first thing I want to do here now is actually import all the libraries we're going to need. So here I'm going to import load fixture. And I'm going to import that from @nomic foundation. And that's going to be hardhat network helpers. So it's going to be this one here. And then I'm also going to import the expect if we want to start, actually writing unit tests. We might want that. And that's going to be from chai. And then here I want to import ethers, but I'm also going to want network from hardhat. And to interact with our Solidity smart contract, we need the ABI. And the ABI is now here in the artifacts. So if I go into the artifacts and contracts and down here to flashloan.json, here is the ABI. It's actually in this file. It's been created for us. And so here what I can do is just go import, and it's going to be ABI, and I'm going to actually call it ABI flashloan with a capital F and capital L just for consistency. And that's going to be from, I'm going to say .. artifacts contracts and flashloan.sol and then flashloan.json like this. And there we go. That will import our ABI here as well. The addresses that I'm going to work with, I'm going to use const, we'll call it WBNB, and that will be equal to an address, which we'll paste in a second. I also want to use BUSD. These are the tokens I want to use for the liquidity pool. But also later on, we'll also use cake because we're going to need another token to interact with. So let's go and get those now. I'm going to go over here to BSC scan, and I'm just going to put in WBNB, and that will bring this up here and copy that address. So the one ending in 95C, there we go. That's that address there. And then I also need BUSD. So let's look for that here, BUSD. And I'm going to go and copy that address here. And then I also need cake. So here, cake, C-A-K-E, which is the PancakeSwap token. And here that ends in CE82, CE82. There we go. So we've got our tokens here. And I'm going to work with a V3 fee. I'm going to call it the Uniswap V3 fee. And I'm going to just set that here to 500. Great. So I've got that set up over here. And so what I want to do now is actually just go and write a quick test. So here I'm going to say describe. So here I'm going to say deploy get pool. So it's going to perform a couple of tests here. And here I'm going to write a function. And that function is, of course, going to return something here. And here I'm going to say it. And we can say deploys and gets pool address. So pool like that, pool address. And then here, let's put in an async function. Same sort of stuff as we did before. And go and actually write that function here. So let's write here deploys. And I'm going to say const flash loan, the capital L is going to be equal to await ethers. And that will be dot get contract factory. And in parentheses there, I'm just going to put flash loan. And this needs to have the capital L now. This is quite important because it needs to know that this is the contract it's working with. So we just put flash loan just like that. And that will create that flash loan. And then here what I'm going to do is say let flash loan, all lowercase, equal to await. And that'll be our flash loan dot, we're going to call deploy. And we're going to pass into it because now when we deploy this, because we have a constructor here in our smart contract, we need to tell it what is token 0, what is token 1, and what is the fee. So I'm going to do that here now. As I deploy it, that's going to be WBNB will be token 0, BUSD will be token 1, and the fee will be the V3 fee like that. And that should go and deploy it as is. And then here I'm going to say await flash loan dot deployed. And in fact, what I'm going to do is I'm just going to fix this V3 fee in here. I'm going to get rid of it there. I'm just going to fix it in here as 500 so that you know we're always dealing with that pull break when it comes to deploying. So here I'm going to say await flash loan deployed, open and close parentheses, and that'll make sure that it's now deployed. And we could even do a console log. So we can say console.log. And here I'm going to say flash loan deployed or flash loan contract deployed. And here we can actually then put in the flash loan dot address, and that will tell us what the address is that it's being deployed to. And remember, we're not doing this on the actual mainnet. This will just be a forked mainnet. And here I'm actually going to put a /tab just to tab across this to neaten up the console.log. Now let me look at our flashloan.sol again. So our pool is actually private. So we're not going to be able to get the pool back out of it. But what I am going to do here is I'm just going to console.log on my actual Solidity smart contract. I'm going to console.log the address of our pool here. And so that is going to print out when this actually runs. So let's go over here to our flash test again and actually just go npx hardhat test. And let's see what actually happens here. So deploy, get pool, and there we go. You can see it's actually printed out this address here. Now, interestingly note, this address ends in 6687. And if we go back over to our factory contract, which I believe might have been here. No, I've been messing around with this. So let me go and get my factory again. And let's whack that in here. So here is my factory. And if I go to contract and I go to read contract, I can get pool. So let's actually go and put in this address. So WBNB, paste that in. And remember, it doesn't matter what order we paste those two addresses in. And here I'm going to say 500. And when I go and hit query, yep, it's the same address. And so this is very important. There's a very important check for you to do. Does this end in 6687 like it does here? This means it's actually computing and calculating that address correctly. And so congratulations, because you have now got a smart contract which you've written from absolute scratch, from the ground up, which is able to deploy and compute a pool address for Uniswap V3. And now that we have that pool address and we're able to get it automatically, you could theoretically pass in any tokens you want, as long as they're valid tokens for Uniswap V3 with a valid fee. It will figure out what that pool is for you. Now that we have all of that, we can actually go and build out the request and the execution parts of our flash loan smart contract. So just to recap that here, we have our flash loan pool address calculation now done. So now what we need to do is actually request the flash loan and make sure that that is executing, and write the code for performing swaps, and then repay the flash loan. And in doing all of that, we're going to need to do some clever testing here to make sure that we're testing a real life type of scenario, because it's very unlikely you're going to find an actual arbitrage opportunity to test. So there's some workarounds for that here that we need to do alongside that as well. So with that said, in the next video, we're going to start looking at the flash loan request itself and start actually making the flash loan request and receiving the funds, and looking into how that all works.